up, and then you can exit the Hangout and switch to, okay, good. We're in agreement on how we're doing this.
Okay, I just tweeted you the
Perfect, thank you. Just wait for that to show up. DM or
public.
Public copy. Great, yep, got it.
Okay.
I am getting in.
Water.
All right, it's going to ask to join. Okay. There we go. You may want to mute your laptop so it doesn't echo my sound.
Yeah, let me,
See, in order to be visible, I have to stand here. Yep, I'm going to stand here just so that I can be seen.
where's that echoing off of?
It's echoing off of your, the projector. It's outputting to the, just set it to, yep, just set your laptop to mute and it'll work.
Okay. Oh, I see it.
Yep, great.
Okay.
There we go. All right.
Okay, and then we'll tweet this out.
Just carefully rotate this so I don't lose that. Okay, I can be seen on the recording. I can be seen here. Okay.
Okay. So, welcome folks to Q1 MonitorSF Meetup. Started this meetup about 3 years ago when I got into observability and monitoring in my day job, and ended up using many different monitoring solutions, and eventually went to work for a monitoring company. But yeah, we've had a few meetups here. I started it because I couldn't really find any meetups in San Francisco that kind of address this topic. Since then, there's been a few that's popped up and down, but glad to have this meetup tonight. I want to give a quick shout out to one of our sponsors, Craigslist, for hosting the space and the pizza. They are hiring. Caleb is out there. If anyone's looking for a job and wants to work at Craigslist, go talk to him. And then give a quick shout out to my employer, Sirconis, who makes IronDB, for giving me the time to work on all this stuff. They make monitoring tools and really scalable time series database.
And they bought the pizza too, I assume.
Craigslist actually bought the pizza.
Oh,
yeah.
Excellent.
Yeah. So we're recording, we're live streaming. Without further ado, announcements. So conferences, there's SRECon in Brooklyn coming up towards the end of March. Anyone going to that? All right. There's Monitorama in June. I think tickets are close to selling out. Anyone going to that one? Okay, cool. And what else is there? Scale is next weekend in LA, basically the open source Linux conference. Other conferences people want to give a shout out to? Other meetups people want to give a shout out to? Serverless Days Boston? Okay. Cool. Right on. All right, well, without further ado, here's Liz.
Hey, this is going to be a little bit of an experiment. You are my canary group, because this is the first time that I'm giving these slides. This is not my first time giving the talk. This is just canarying, giving the slides, giving a new set of slides with the same talk. So hi, I'm Liz Fong-Jones. I'm at Liz the Gray, and I currently work at Honeycomb as of Tuesday, which is super exciting. So today I wanted to talk to you about effective service level objectives, but I think it's useless to talk about a specific technical term without talking about the context. So let's start with some context. So I presume everyone is here because they like monitoring, or they're interested in monitoring, or like something about monitoring is really fascinating to them and they really enjoy it. But I think that maybe enjoy is not quite the right word, because unfortunately, a lot of people hate their monitoring. That's a true fact. How many of us hate our monitoring sometimes? Yeah. It's kind of difficult, right? So I think that we have to go back, right? We have to go back and think about all of the things that give us grief. our alerts are super noisy, right? We got woken up in the middle of the night for things that we don't really care about. Or when it is time to debug a problem that we can't figure out, what are all these dashboards? What idiot made that dashboard? Oh wait, it was me 5 years ago, right? Like, stuff like that makes it really, really challenging to understand our systems. And therefore, we have to think about how are we going to solve these problems, because we have to think about the job that monitoring is supposed to serve. The reason that monitoring exists is to tell us when are things too broken. And when things are too broken, how do we debug the problem? How do we figure out how to restore our services back to a nominal state? Not necessarily perfect, but good enough. But it's really, really challenging to get that right. And unfortunately, a lot of things that we've tried in the past are things that people have now moved on from because there are better ways of doing things. And one thing that I think is especially key to this is thinking about the idea that our systems are always failing. That when you run a sufficiently complicated system, you can't care about one single query failing or one single server flopping. You just can't care about that anymore, or you'd be up all night. So we have to think instead about what this notion of too broken means, of what it means for a system to be operating beyond the normal amount of brokenness. So I want us to focus on the idea of what too broken means. And I think for that, we need service level indicators to come to the rescue and save us. That service level indicators are our way of measuring what's broken but not too badly and what's too broken. So let's think about how we might define this concept of the service level indicator. So let's think about concrete events that might happen in the lifetime of your service, right? If you're operating a service where someone might want to pin, like Pinterest, right? Someone might want to pin specific web pages that they found on the internet and save them somewhere, right? Every time someone tries to save such an event or save such a page, that might be an event, right? And it either is going to succeed or fail, and it's maybe going to take a certain amount of time, right? So we need a quick way of sorting these events that are discrete items into whether they're good or bad. And based on that, we can figure out, are we too broken or not? So for instance, I might say, okay, for the example of trying to save a pin, that an event is good if it has an HTTP 200 turn, so not like we're serving errors, and it takes less than 300 milliseconds, because we know that people start mashing the button multiple times if it takes more than half a second, so we want people to be satisfied enough with the condition of the service. So that tells us whether any one page load was good. But then there are other things that can happen that are not necessarily single web page loads, right? You might have a batch job. You might need to process payroll for a couple thousand or a couple tens of thousands of employees, or maybe you're Gusto and you're trying to pay people at hundreds of companies, right? So then we need to think about, did we process this company's payroll within the correct amount of time, right? To start thinking about individual rows of data as, is this fresh enough? As opposed to, did this specific hit to my web server succeed? Because let's face it, we all like being paid on time, right? Okay, so the core idea behind a service level indicator is that it lets you bucket events into good or bad, and then based off of that, compute how many total events did we see and how many of them were good, what fraction of events were good. So that's your service level indicator, which is a measurement of instantaneous availability. It says what proportion of your events were good. But the problem is that knowing that my service was, within the span of an hour, 99.99% up doesn't really help me if the next hour I'm 100% down, right? Like, we have to have some way of aggregating this data over larger timescales in order to make sure that we can actually make business decisions based off of this data. So we need to set a target. What are we aiming for? And that's called the service level objective. So we need the window, how long are we aggregating over, and what are we trying to reach in terms of percentages? So for instance, I might say that I'm targeting 3 nines of availability, right? That I'm targeting having 99.9% of total events be marked as good out of the total over the past 30 days. And that means that I could tolerate, for instance, a 0.1% of that 30-day window being 100% down, Or I could even measure partial outages that way, right? Like if you have a brownout of your service and 10% of your errors are seeing, 10% of your users are seeing errors, you want to be able to granularly think about that and think about how does it impact the total perception of your service by users. So if you define an SLO that's really, really good, it's the bare minimum that it takes to keep your users happy, right? Not excessively high, and not to the point that your customers are leaving you, but the baseline expectations that your customers have. The reason that we don't set it much higher than that is because then you're making a bad trade-off. You're saying, I would rather be slower to ship features than my competition in the spirit of trying to keep the mythical user who cares about 100% availability happy, right? No one actually cares about using a service that is useless because it doesn't have the features they need, right? People need the right mixture of availability and of features. So once we've defined this target, we can use it then to alert. We can use it then to really be the one thing that we care about. Is the service working well enough? Because if there is a real problem, it'll percolate back to our top line metrics and we'll find out. But if something is subtly broken, but it doesn't matter to the end user experience, we don't need to keep ourselves awake at night over it. So we can use this target and only this target to do our alerting. So if things start trending in a bad direction, we want to be able to notice and we want to be able to take action to bring the system back to a normal state. And if things are not just trending badly, but are completely on fire, we obviously need to know about that too. So how can we get the best of these both worlds? The way that we like to think about this is the idea that an error budget is 1 minus your service level objectives target. So if I say that 99.9% of queries are expected to succeed over the rolling 30-day window, that means I'm allowed an error budget of 0.1% of those queries over that window. They can be errors, right? I can run experiments, I can tolerate some planned downtime, or we do have to plan as well for occasional downtimes that are not expected to happen to eat into that error budget. But it turns the idea of chasing infinite nines instead into the idea that we think about how we meaningfully and thoughtfully spend that error budget, that it's there and it's meant to be spent, right? It's the same way that we keep food budgets, right? Like if you know that you want to spend, let's say $300 a month on food, right? You're not just going to say, I'm going to spend $0 on food every single day, right? It's there to be spent. And that lets us do interesting things, right? It lets us compute how long is it going to be until I run out of error budget? Because that's really the thing that we care about. And if it's a number that's measured in hours or minutes, then you definitely need to be waking someone up, right? That if you allow that state of affairs to continue, that you're going to be in a really bad situation because your users will no longer be happy. But we also have to care about the longer term situations. Like if our error budget says we're allowed to serve 0.1% errors and we start serving 0.11% errors, then maybe we need to do something about it, but not necessarily tonight, maybe tomorrow during the day. So we can use either email or your ticket tracking system of choice in order to look at these things and do longer term investigations if we're only slowly doing worse than we're expected to. And the beauty of this is that not only is it useful for detecting what's only a small blip that you can tolerate and what you need to deal with now, you can also use it to make business decisions. For instance, should we invest in more reliability, right? Do I need to go and deploy my service to another Amazon availability zone? Well, maybe, right? It depends. Is your service performing well enough that you don't need that level of extra reliability to keep your customers happy? Or is that an investment that you need to make because that's the spec that your customers are expecting? Or in the converse case, right? Let's suppose that you're trying to decide whether to push out an experimental new UI. Now you could sit on it and validate it and test it for 2 months. Or if you have lots of error budget left, why not just push it and see what happens if you know that there's plenty of error budget left and you can roll it back if there are problems and not meaningfully dent your error budget. So this is a really powerful way to think about how can we move faster while keeping our services reliable enough. And I think that it's important to have any line in the sand that you draw. Like, to have any service level objective rather than having no service level objective. Because you really can't measure what you're not actually monitoring. And if you don't have that data, you can't make those decisions, and you wind up back at square zero at the beginning of the talk where we were saying you get woken up by every single thing that goes bump in the night, whether it matters or not. And over time, yes, you can make your service level objective better and better, but you don't necessarily have to have a perfect SLO to start using this as a way to think about the availability of your service. So measure what you can today, and do these alerts only on when your service level objective is in danger. And you'll find that you sleep a lot easier at night, and your customers will still be just as happy with your service. And over time, if you discover that your service level objective is too strict, you can relax it, right? If you have an outage and your customers don't really complain, well, maybe you can relax your SLO. Or if your customers are unhappy with your reliability, then maybe you need to slowly tighten it over a period of several months, rather than having your system tell you the system is too slow. Yes, I know, we're working on it. Give us a few months to push this new improvement, right? So you can iterate on this in order to find out what is the right level of availability that balances the speed of execution and the availability of your service. But I think that there's another piece that's really important here, which is a lot of people tell me, Liz, like, I'm terrified. You're telling me to turn off all of my alerts, right? And that's true that when you turn off all of those little alerts that tell you anytime something goes slightly bump in your service, that you do need better tools to debug what's going on. And I think that the best way to think about this is to think about how can we dive into data to ask new questions, right? How can we figure out when we get paged where in the system is broken? And it may not be something that we've thought about instrumenting before. Because our outages are never really identical, and you can't really get to this ideal state by monitoring the last thing that broke. And that's true regardless of whether or not you adopt service level objectives. Because if you wind up chasing the past, you wind up having a magnifying glass on one tiny patch of the ground when there's this giant bug behind you and you're running around going, ah, as soon as you turn around, right? Like, that's not a really great situation. So don't assume you know what your failure modes are going to be in advance. And instead think about how are you going to find the next new failure in your system. And once you have some combination of that and service level objectives, then you'll really be able to only get alerted when users are impacted, and you'll be able to figure out what's going on in that situation. And the ugly truth is, if you're monitoring and alerting on everything, you're not going to be able to find that anyways, that you're going to be drowning in so many alerts. So think instead about more sustainable approaches. Because our systems really can be more reliable to our users and more friendly to us as the people who run them. We just really have to make them observable. We have to invest in that ability to understand what's going on in them, and also in service level objectives to help us figure out when is the system actually broken enough for me to care. So that's the talk. I think I ran a little bit quick, but I imagine there will be a lot of questions, so I'm happy to take people's questions. Yeah.
How do you go about tying business level facing events, things which affect the user, to the concrete kind of like looking at code bars, looking at status codes, looking at latencies? Is it just a matter of just knowing your code sufficiently well, or is there a technique for tying the two together?
I think that a really great approach for being able to go from the top of your stack all the way to the bottom of your stack is kind of the idea of being able to bisect, right? Of being able to narrow down by eliminating halves of the infrastructure, right? If you can say, okay, I'm staring at this error, and I know for a fact that the web server received it, then I don't need to worry about the load balancer, right? I know the load balancer is not the problem, right? So you can kind of bisect in order to get to the bottom of problems that way. Did that quite answer your question, or?
I was really more wondering, how do you begin developing this, like finding the things to measure with which to alert off to begin with? I guess I'm trying to work out how to ask the question. Yeah, it's okay. I'll think about it.
Okay, let me answer another question you might have asked, which is how do I figure out what my service level objective should be, what the top level objective should be? And I think that the two things that most people care about if it's an interactive service are did I get an error and was it fast enough? And if you're measuring those two things across a broad swath of your traffic, it doesn't have to be end-to-end at first, but ideally, if you're running an e-commerce site, for instance, someone should be able to add browse for items, add an item to cart, check out, right? Like that should be one set of events that if it's interrupted, there's a problem, right? But you can just start with just saying, measure all of my web traffic that's not API, random robot API endpoints, right? And just measure all of that and measure percentage of HTTP 200s and response latencies. Like, yes, you can get more granular, but again, imperfect is better than nothing. Yeah.
How do you think about managing error budgets within teams? Like, how do you deal with the problem of this person spent the entire error budget, so no, we don't have any?
I think the best way of dealing with spending the error budget in between teams is you can allocate the error budget in terms of your various backends, right? You can say, you know what, if I know that the top level service level objective for my company is 3 nines, then maybe I shouldn't run on a database provider that's also 3 nines, because that leaves me no slack for my front end, right? So it forces you to think in advance about your design constraints and have those conversations up front rather than during an outage. So I think that it's a much more grown-up way to handle the budgeting process is to allocate it to your teams, be aware of, communicate your SLOs, and if someone can't meet it, then you need to revisit, do we really need that dependency? Can we add a retry, right? Like these are all things that you can start exploring if you have that conversation about, is this meeting my needs or not? Yes.
Have you had conversations with business executives about, why do we even need an error budget? Why can't the service be up all the time?
Yes, the 100% question. The way that I answer that when executives ask me, can't I have 100% availability, is every time you approach 100% by an order of magnitude, you make it 10 times more expensive. Do you really want your service to cost $100 million? Do you really want to reproduce Google's infrastructure? You probably don't. You probably can't afford it. That's generally the answer that I give. So it's basically saying, look, the cost is too high both in terms of infrastructure cost and opportunity cost of running at a higher level of availability than you actually need. Deirdre.
And that's applicable to a Google-sized company, but what about something that's smaller, an organization that isn't that scale?
The general concept of SLOs, or?
No, just on that follow-on to that 100% question.
Oh, about 100%, right? Like, I think the argument is a small organization can't afford to reproduce Google's infrastructure.
Yeah. Oh, okay, gotcha.
Yeah. The argument is if you wanted to do that, you'd effectively be competing with Google and spending Google's amount of money on R&D, which you probably can't afford. Yes.
So we're talking about a service level objective. Do you want to think of a service level objective for the entire company or for different services?
My viewpoint is that companies do need top-level SLOs that reflect the overall success of the business, or at least of each business unit. However, they are a bit unwieldy to work with, alluding to the problem that Emily talked about of having various teams squabbling over you spent too much error budget, right? So I think that every time you have a boundary between teams where you're handing off one set of services run by one team to another set of services run by another team, that's the appropriate place to put into place that language about what is the service level objective of this set of components. And that way you can reason about, is this chain of dependencies getting to be too much, right? Is everyone in alignment about how reliable each part of the stack is supposed to be?
I was thinking in terms of priorities, like an error while I'm trying to process a payment is not the same as when I'm trying to modify my profile.
Yes, definitely, and that's why I said, like, you can start by measuring 100% of your web traffic and looking for percentage of 200s, right? But that's not ideal compared to figuring out what really matters in your workflow and what doesn't. So you may want to choose not to have an SLO on doing searches compared to if someone wants to give you money, make sure absolutely sure that can succeed, absolutely. So it's fine to, once you have an SLO, to specialize it and say, we're going to have a much higher SLO for the payments part than the rest of it. You look like you're about to ask a question.
I was going to ask, does it also imply then that the responsibility for a particular service must be owned by a particular team you're measuring the time? In the case of flows which cross multiple teams, you presumably can't meaningfully single SLO on that. Is that a fair statement? Or?
Yeah, I would say that if you have a workflow that touches multiple teams, you may want to have one SLO for the overall interaction, but in order to make it manageable, right? Unless you want the SLO being violated to mean no one can push on any of those teams, for instance, that's one punitive way to approach the SLO, is to say, if you exceed your error budget, that you are not going to do any non-bug fix pushes, right? But people then generally tend to chafe at that because they're like, hey, wait a minute, why did this other team's action cause me to no longer be able to push my code, right? So that's why it's better to have a safeguard to stop teams from overrunning the entire error budget sooner if you can decompose it into saying we have an SLO for this set of APIs and then this downstream set of APIs is a different SLO, and the sum of them adds up to the correct number. Funny example from my time working on Google Book Search. It turns out that if your backend is too slow, you know how if you load Google Web Search that that'll sometimes show these custom boxes at the top that say, you know, top news or top books, right, about the subject? Okay, so those are done by a different backend than the main search backend. But if those are too slow, Google Web Search will protect itself and kick you out of the set of backends that it talks to temporarily in order to make sure that it can achieve its overall SLO, right? So you have optional backends. That's one way of preventing one of your optional backends from overrunning your entire SLO by making your service too slow.
So you have graceful degradation.
Yeah, exactly. Like graceful degradation lets you protect your SLOs much better than hard degradation, right?
Would you say that it's better to start at the top level like that?
I'm of mixed opinions. Definitely, I know that the corporate reality in many companies is that you can make an SLO for your team, but you can't necessarily enforce an SLO in the whole company. So my answer is very different depending upon whether you're an executive or whether you're a individual contributor or a manager on a team, right? I think that if you can't, you know, I think it's important to set goals for ourselves. And I think that setting an SLO for your team is one way of publicly communicating to the rest of your organization. These are our goals. We're going to hold ourselves to them. Speaking of holding themselves to them, you'll notice that I did not say the word service level agreement in this talk. There's a reason for it. A service level agreement is a legal construct. It usually has only some bearing on the SLO, in that usually the lawyers insist on adding some extra margin between what you can reasonably achieve and what they write into your customer contracts. So if your SLO and SLA are grossly out of line, your company is probably paying a bunch of money back to your customers or refunding them, right? So it behooves you to actually write down a realistic SLO so that you can go to your lawyers and have that conversation of, you know what, that SLA that you wrote, like that is not realistic, we have to renegotiate, right? So it's a business level construct more than a operational construct that we use to manage our services. Yes?
Have you ever heard of, I think I've heard of, I guess I would call it like an error budget spiral of death, where maybe you have a really big outage and then people get scared and they don't want to push anything, but the problem is still there.
Yes. This is a fascinating property, especially around things like holiday freezes. Some people love holiday freezes, some people hate holiday freezes. It is definitely riskier the more changes you batch up before releasing. I think it's not so, the death spiral doesn't so much come from people being afraid to fix the bug, as what happens in the week after you say, okay, all clear, the SLO has recovered because there's been long enough elapsed of stable service, okay, let's go and release the past 3 months of features. Oh no, another big outage, right? I think that's the real danger that can happen, and I think that the way to be more thoughtful about that is, instead of thinking about bug fixes versus features, instead to treat reliability as a feature. So if you know that you've blown your error budget for a while, don't just keep on accumulating features to the backlog, right, that are going to be released. Instead, divert that effort of those software developers into working on structural fixes to the reliability, on making infrastructure fixes. That way you're not accumulating months of features that are going to break the service. So yes, that is one way that is less punitive than let's stop all the pushes, is to instead say, if we blew our error budget last month, let's put into the next sprint half of the items to be reliability and infrastructure instead of features. All right, going once. Yeah.
So are you talking about the hierarchy and like breaking SLOs down? Do you, like as a team, let's say
It depends. It is definitely true that the thing that GCP found relatively quickly after previously having Google infrastructure mostly be used to run Google search and Gmail and so forth, right, is that customers of GCP really, really care if their service is down, even if you can't say, oh, 99.9% of users are happy, right? People are sending angry phone calls to your VP if their individual service is 100% down. So it is important to have per customer monitoring if your service is very contract driven. However, if you're operating a consumer service, kind of less so. So it depends upon your needs. The danger of doing alerting at too high of a granularity is that when you do that alerting at too high of a granularity, it increases the odds that you'll have a momentary blip in one user with low queries per second, and that will be like, oh my god, this user 100% down, right? That may not actually be an emergency. So it depends on your business needs. That's not a answer with a clear-cut yes or no answer. All right. And lastly, I do think that now that I work for a startup, I can put the obligatory, we are in fact hiring. So thank you for having me. And let's feel free to approach me if you want to chat with me while we're mingling. Thanks.
Excellent. Thanks, folks. If anyone else is interested in speaking, hit me up. Contact me on Meetup or talk to me tonight. Thanks. And I think we have more pizza back there.